Hey everyone, and welcome. I am absolutely thrilled to have you all here for today's explainer on component-based software engineering processes, or CBSE for short. If you're tackling this for the very first time, you are in exactly the right place. This is a massively important lecture for your module, and honestly, it's going to fundamentally change the way you think about building software programs. So grab your notes, get comfortable, and let's jump right in.
Right, let's quickly check out today's agenda. We'll start with an introduction to CBSE processes, then we'll break it down into two main areas, development for reuse and development with reuse. After that, we'll dive into the Ariane 5 disaster, and finally, we'll wrap up with your summary and exam focus.
Okay, Part 1. Introduction to CBSE processes and why this is such a fundamental shift in software engineering.
Basically, this entire approach is moving us away from that old-school method of writing every single line of code from scratch. So what are CBSE processes? Well, they're the specific software processes designed to support the defining, implementing, and integrating of loosely coupled, independent components into systems. Think of it like a giant bucket of Lego bricks. Instead of melting and molding the plastic yourself to build a custom shape, you're taking pre-existing, totally independent pieces and just snapping them together. It's an approach that's custom-built for large-scale enterprise systems, where you really need to deliver secure, highly dependable software, and you need to do it fast.
Now, the really interesting thing about the CBSE landscape is how it splits into two totally distinct processes. On one side, you have CBSE for reuse, and on the other, you have CBSE with reuse. These are completely different activities. One is all about producing components, and the other is about consuming them. You'll also notice there are vital supporting activities holding it all together, things like component acquisition, management by a librarian in a repository, and component certification, where an independent certifier comes in to guarantee the quality of the part. The whole system has to work together to make reuse a reality.
All right, moving into Section 2, development for reuse. This is where we focus on the producer side of things. Let's start by defining it. Development for reuse is the process of developing components or services specifically intended to be generalized and reused in other applications. And I really want to emphasize something here. Building a component for someone else to reuse requires a totally different mindset than building something just for yourself. Think about it. You might have the source code right in front of you, but your actual goal is to generalize it so much that it fits into future applications you haven't even dreamt up yet. Because of that uncertainty, it is so much harder and significantly more expensive to build a reusable component than a highly specific one. Now, we need to bust a bit of a myth here. Back in the day, early supporters of CBSE thought there was going to be this massive, thriving component marketplace. They pictured developers just hopping online and buying off-the-shelf software components from specialist vendors. But honestly, that vision just never fully materialized. Buying external, off-the-shelf components is actually quite rare. Instead, most for reuse development happens completely internally, usually within very large organizations. Companies essentially build up their own private library of trusted components so they can reuse them across their own software programs.
So, because making a component reusable is so incredibly expensive, you have to justify the cost. And you do that by ensuring it represents a stable domain abstraction. What does that actually mean? Well, it means the component represents a fundamental, core element of a business that changes very, very slowly. For instance, in a banking system, an account is a stable domain abstraction. In a hospital system, it's a patient. If your component handles a rock-solid business object like that, you know it's going to be needed over and over again, which totally justifies the upfront investment.
Once you've found that stable abstraction, how do you actually generalize the code? Well, there are three specific technical steps you have to take. First, you strip out any application-specific names and swap them for general ones. Second, you add extra methods to provide broader functional coverage. Basically, you add features that your current application might not even need, but some future application definitely will. Third, you customize the code to ensure exception handling is perfectly consistent across all methods. Stripping out specific behavior and bolting on generic interfaces adds a ton of complexity, but it's literally the only way to make the code truly reusable.
There's actually another brilliant source for reusable components, and that is legacy systems. You know those old, incredibly valuable systems written in totally obsolete technologies? To reuse them, we use something called a wrapper. It's exactly what it sounds like, a modern layer of software wrapped right around the old legacy code. It hides all the messy, tangled complexity of the old system and provides a clean, modern interface for new components to talk to. It's a lifesaver because it lets us convert aging programs into reusable components without having to spend millions rewriting them from scratch.
Okay, quick recap on development for reuse before we flip the script. It's all about creating generic, robust components. It relies heavily on stable domain abstractions. It demands the really expensive work of removing specific names and adding generic methods. It frequently uses wrappers to rescue legacy systems. And finally, it requires strict component certification to guarantee quality. Keep all of that in the back of your mind as we shift over to the consumer perspective.
Right, Section 3, Development with Reuse. Let's see how we actually build things using these parts.
Development with reuse is the process of building new applications by discovering, identifying, and integrating existing components and services. When you're the consumer in this process, you're literally just snapping the parts together. The catch: you generally do not have access to the component source code. That fact alone completely changes your entire development strategy. You don't always know exactly what components are even out there when you start a project, so you have to design your system to make the absolute best use of whatever you can manage to find. And guys, this is a massive exam topic. You have to be able to contrast these two processes. Development for reuse is the expensive, time-intensive process of creating generic, robust parts for a wide audience. Development with reuse is the fast, consumer-driven process of taking those existing parts and snapping them together. One is manufacturing the bricks, the other is building the house. So how do we actually go about building that house? There is a 4-step process. Step 1, outline your requirements. But, and this is absolutely critical, they must remain flexible. If you are too strict here, you will literally never find an existing component that perfectly fits. Step 2, identify candidate components. You search, you select, and you validate what's out there. Step 3, you modify your initial requirements based on the components you actually found. Finally, Step 4, architectural design and composition. You are constantly trading off your dream requirements against what the existing components can actually deliver.
To quickly summarize development with reuse, your entire focus is finding and integrating what already exists. Because of that, your requirements have to be flexible from day one. You're going to spend a massive chunk of your time searching, selecting, and rigorously validating these components. At the end of the day, saving time on coding means spending a lot more time on compromise. You have to be willing to bend your goals to fit the reality of what's available.
Which brings us nicely to Section 4, the Ariane 5 disaster, a truly legendary case study in software failure.
Please pay close attention to this because it is highly testable. It perfectly illustrates what happens when validation goes wrong in reused software. This is the story of the sheer danger of unnecessary functionality. Back in 1996, the European Space Agency was launching its brand new Ariane 5 rocket. To save some time and budget, engineers decided to reuse the inertial reference software, the system that essentially tells the rocket which way is up, from the older, slower Ariane 4 rocket. Now, this was phenomenal software. It had worked flawlessly on Ariane 4. But they reused it without making changes, dropping it straight into a new, much faster rocket.
So here is the technical breakdown of why it failed. The reused software actually contains some functionality that Ariane 5 didn't even need. Specifically, a fixed point to integer conversion calculation. Because the new rocket was so much faster, the speed data generated during flight was massive, much larger than Ariane 4 ever produced. This caused a numeric overflow. The number was just way too big for the software to convert. This triggered an unhandled exception, which instantly crashed the rocket's entire guidance system. Just 37 seconds after liftoff, the rocket veered off course and self-destructed, taking a multi-million-dollar satellite payload with it.
The exam lesson here, the absolute golden rule you need to remember, is that when you reuse a component, you are never just reusing the code. You are inherently reusing all the assumptions the original programmer made about the environment it was going to run in. The Ariane 4 programmers assumed a specific maximum speed. And the scary part? Those assumptions are almost never documented. If your new environment breaks those hidden assumptions, the component will fail. That is why rigorous, exhaustive validation in the new operational context is absolutely mandatory.
All right, let's wrap this up with Section 5, Summary and Exam Focus.
We have covered some serious ground today, so let's pull all these critical threads together for your exam prep. Here is your ultimate checklist. First, you must be able to contrast development for reuse, which is building generic parts, with development with reuse, which is assembling those parts. Make sure you've memorized the definitions for stable domain abstractions, wrappers, and CBSE processes. Know the 4 steps of development with reuse inside out, especially the part about keeping requirements flexible. And lastly, be ready to explain the Ariane 5 disaster as the ultimate example of why reusing environmental assumptions without validation is a terrible idea.
Getting a handle on these concepts will set you up perfectly for our next lecture, where we dive into component composition.
Before we go, I want to leave you with a bit of a provocative question to chew on. We've seen that reusing software is amazing for speeding up development and cutting costs, but it requires a lot of caution and compromise. So, if every single reused component inherently carries the undocumented assumptions of its original programmer, just like we saw with Ariane 5, can you ever truly validate a modern software system without just rebuilding the whole thing from scratch? That's a tough one, right? Have a think about that as you study. Thanks so much for tuning in today, and I'll catch you in the next lecture.